All right, boys and girls. For those of you who are in first period, you got this lesson. And the rest of you got this lesson from Ms. Phillips. And so I thought I would just go ahead and record on here and go through the notes myself, just so you had it to refer back to if you needed it for your assignments today and to finish your assignment from yesterday. So this is the notes from December 4th. This was Wednesday. Okay, these are notes I need you to keep in a folder or a binder or somewhere, because you're allowed to also use these notes on our test when we take our tests. All right, so we're going to talk about scatter plots and association. In order to do scatter plots, you do have to know how to graph. Everyone, I hope, knows that to graph, you go horizontally first and then vertically, so left to right, then up or down. I know that's a little different from when we talk about slopes. I know that gets a little confusing there. So when we graph on graphs, we go horizontally, then vertically to make our point using the two data points. Okay? We're not going to make graphs today. That will be, I believe, tomorrow. But just to kind of throw that in there. All right? So if you'll kind of follow along with the notes, if you haven't already, if you don't already have these, I will also post the one for tomorrow as well, or for Thursday's work as well. Okay? All right, so starting off, scatter plots and association. Scatter plots are graphs that are used to display numerical data, meaning numbers, right? With two variables. Variables meaning independent, dependent, or we also call it bivariate data. Okay? All right, so remember that variables, you may have heard this in science, independent and dependent. So that means one variable is dependent on the other variable. So when it's like kind of like cause and effect, right? One variable could cause the other one. So we're going to talk about that here in a minute, about if things have a relationship or not. Okay? Scatter plots can help determine if one variable has an effect on the other, or if there are overall trends, patterns, or we call them associations between the variables. So again, we're going to look at, does one cause the other, kind of that cause and effect, independent and dependent. All right, so let's look at this first problem. It says Susie went to the mall and surveyed shoppers to see how many items they purchased and the total amount of money they'd spent at the mall. She created the scatter plot below. So she created this using that. So the first question said, how many shoppers did Susie survey? Well, looking at here, we have the number of items and the total amount spent. So every single dot here is somebody she surveyed, because that's a point of information. That's a point of data, okay? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. She interviewed 16 different people. Okay, sorry for this weird little shadow right there. Does the number of items purchased seem to have an effect on the amount of money a shopper spends? So explain. So if you notice, as we buy more items, it's numbered 1 through 10 down here. As we buy more items, you see that the total amount we spent also goes up, right? Here's the amount spent. Okay. So we can say, yes, it does have an effect. And the more items we buy, the more money we spend. Okay? Okay, so this next part, we're talking about associations. Positive association. When I think of positive, I think of something going up, right? Of rising. So two variables have a positive association when the variables move together. For example, as one variable increases, the other variable increases. Just like that graph we just looked at. So as this one increases, as we go this way, we also go up, right? So this is increasing. Think about slope. This would be like a positive slope, okay? The next one is negative. So a negative association, two variables have negative association when the variables move in opposite directions. For example, as one variable increases, the other variable decreases. And if you look at this, you can see like a negative slope, right? Sorry, those aren't quite on the screen. You can see like a negative slope, okay? As this one goes further down this way, these go down in this direction. All right, and then our last one is no association. No association means that two variables have no association when the change in one variable has no effect on the change in another variable. Okay, so if you notice the points on this graph, what do you see? They're all scattered around. So it's like somebody threw them on there and they landed where they landed. Okay? All right. So in class, we talked about a few examples. We talked about if somebody was 6'9", would you think they'd wear a smaller shoe or a bigger shoe? Probably a bigger shoe, right? Because they're going to need a big foot to hold that foundation. So you could assume that the taller someone is, the bigger their foot is, right? There's an association there. Now think about this. Does my shoe size affect the grade I make on a test? No, right? So there's no association there. There's no relationship. Okay? And we're in the middle of winter and we're going into night. So as the hours increase, my temperature is going to drop. Middle of winter, right? So we're going to get colder. So that's going to be a negative association. Okay. So now we're going to talk about the type of association we'd expect to see between the following. All right. So A, the hours a person studies and the number of states they visited. Doesn't matter how long I study, right? Traveling doesn't matter how much I study. Doesn't matter how many states I've been to. So for this, there is no association. Okay? The next one, the hours a person studies and the grade on their exam. I can assume that the longer they study, the higher their grade's going to get, right? So this is a positive association. And then finally, the hours a person studies and the hours they spend watching TV. I can study all night long and not watch TV at all. Or I could study for 4 hours and watch TV for 4 hours. My studying does not affect my TV. I'm going to go back. The hours a person studies and the hours they spend watching TV. The more I study, the less time I have to watch TV, right? So the longer I study, the less time I have to watch TV. So that's going to be that negative association. Okay. There is a back to this. So let's look at the back. And this will help you if you haven't finished that page or if you were absent on Wednesday. This will help you with that. Okay? All right. If a straight line can be drawn to follow the overall trend of the scatter plot, then we're going to call that linear. And that shouldn't be a new word to us, right? Linear means a straight line. If the points of data are close together, I mean, they're kind of clustered and they're tight, the association is called strong. But if the points of the data are widely spread, they're spread apart a little more, we call that a weak association. Okay? So looking at this right here, we're going to tell whether each one is positive or negative, whether it's strong or weak, and whether or not it's linear. So when I look at number 1, from left to right, they're all moving in an upward direction, right? I could basically draw a line right through the middle of that. So this has a positive association. Okay? But you notice they're pretty close together. So this is going to be strong. And I just mentioned I could draw a line right through the middle of that, right? I could go like that. So this is also linear. All right, let's look at the next one. Again, you can see that positive trend, right? It's going upwards. We're going to say this is positive. Do you think it's strong or weak? Look at our strong, how closely they are together. These are a little more spread out. So we're going to say this one has a weak association. And again, I could still draw that line to the middle of them. So this is still linear. Okay. Next one. I can still see that upward trend, right? They're going up as I go there. So this is still positive. And they're pretty tight together. They're not too far apart. So I'm going to say this is still strong. However, what did you notice about my line? It's curved, right? So this one is going to be non-linear. Okay, so looking at the next one. What do you notice? They're going down, right? Down. So these are negative. But you see they're pretty close together. So we're going to call this a strong association. And then you see the straight line that I was able to draw through. So they are linear. Okay, look at the next one. What do you notice? It is negative because it's moving in a downward direction, opposite, right? As one increases, the other one decreases. You see these are a little more spread out. We could call this a weak association. I think can be okay. But this one is non-linear. You notice my line curves. Okay? And then this last one, no association. Because they're just like paintballs. They just got thrown on there, right? They're scattered everywhere. There's no association there. We're also going to say it's weak because we don't see any association. There's nothing close together. And since they're not together, it's obviously non-linear. Okay? Okay, describe the type of association you would expect to see between the following variables. A person's height and a person's shoe size. So we talked about that earlier. The taller the person is, the bigger their shoe size is. So we would expect to see a positive association. Okay? This one, the number of letters in a person's name and a person's IQ. What do you think? Right, they have no association. There's no relationship there. And lastly, the number of absences a student has and a student's GPA. GPA is their grade point average, right? So if you're absent all the time, the more you're absent, what would you think is going to happen to your grades? Your grades are going to drop, right? So this has a negative association. All right, lastly, we're going to match these three, okay? So here I see it's going downward. This one is going upwards, and this one's kind of scattered all over the place, okay? Now I have A, B, and C to match. A says the temperature outside and the total gallons of gas sold at a gas station. Is there a relationship between the temperature outside and how much gas is bought? Think about that. The next one says the size of a home and the cost of monthly utilities for that home. So is there a relationship between how big the house is and how much they spend on electricity or water? And then lastly, the third one says the altitude of a hiker and the total oxygen level in the air. So it's talking about how high you are on a mountain and what's happening to the oxygen level. Okay? Some of those are a little tough because we may not know some of those. So as you go higher in the mountains, your oxygen levels drop. The oxygen levels drop. So this is going to be a negative association. So this one's going to be C. We have that negative association. Okay? I can assume that the bigger my house is, the more my bills are going to be. The more it's going to cost to heat my home or cool my home, or the more water I'm going to use. So this one we're going to put B. And then there is no relationship between the temperature outside and how much gas is sold at the gas station. So that's a no association. Okay, so I hope this helped for Wednesday's work. You may still be working on it. But again, this was for Wednesday, December 4th. And I'm fixing to post the other video for Thursday the 5th.